What is going on inside the ESP32? Well, first, let's find out what is inside an ESP32. Now, this is the actual chip, but a common misconception is that this is the chip. In reality, all of this is just the dev board, which provides some quality of life features, such as an LDO, USB ports, a USB to UART bridge, and buttons. If we remove all of that, we're left with just the chip. But on the outside, there's a metal casing, which is an radio frequency shield. Removing this, we're left with four main parts: the antenna, the crystal oscillator, the SPI flash memory, and the ESP32 D0WDQ6. Inside the ESP32 chip, we can find all of these features. Now, the main stuff is in the core and memory section. First, the microprocessors. These are Extensa 32-bit LX6 microprocessors, and there's two of them because each one accomplishes a different task. The first one is the protocol CPU. This handles Wi-Fi, Bluetooth, and peripherals. Second is the application CPU. This is the one that actually runs your code. Next is the read-only memory. This is etched into the silicon, hence the name read-only, and it holds startup routines such as the ROM bootloader. Next is the static random access memory. This stores the stack used in your program, stores the variables used in your program, and also some runtime data. There are also some other features in this chip, such as the real-time clock, which handles power modes, deep sleep, and timed wake-up. There's also some features for Wi-Fi, such as the MAC, which is the unique identifier, and the baseband, which handles basic communication protocols. There's also something similar for Bluetooth, the Bluetooth link controller, which handles connecting and disconnecting and other lower level tasks, and also the Bluetooth baseband, which handles communication protocols. Now, how is code actually executed on the ESP32? Well, your code might look something like this, which is written in C++ or another high-level programming language, and this code turns an LED on and an off. To get it onto the ESP32, the first thing you need to do is convert it to an object file. The object file is just a bunch of ones and zeros, but before you can put this onto your chip, you need to join it together, link it with all the other libraries or other object files that you use. Once you link all of those together into 3 files. The first file is the bootloader, which is the initial program that runs when the ESP32 is powered on. Then is the partitions, which has a partition table showing where everything is in the memory. And lastly is the app, which is your code. Now, these 3 binary files are put into the SPI flash memory. Now, when the ESP32 is powered on, the ROM bootloader, which we talked about before, turns on. This is etched into the silicon, and all it does is find the bootloader. Once it finds the bootloader, the bootloader initializes some hardware, and then it uses the partitions to find the application in the memory. Now it's time for the ESP32 to work its magic. The code might look something like this, in which case the setup is first run one time on the microprocessor. Then the loop is run over and over again until the program is terminated. The end. Hope you guys enjoyed.